it's really awkward to stand in the kind of podium in front of the stage. I was worried that your fly is open. Maybe Phoenix Perry could lend me a Game Boy and I could just shove it down my crotch and then I wouldn't have to worry about that. Anyway, awkward. I'm a very serious researcher, actually, even though maybe it doesn't seem like that from this introduction. I'm a PhD student at the Center for Bits and Atoms. I work in a basement full of toys on machine design, machine control, and spatial computing, and a bunch of other stuff like that. And in this talk, I want to talk about sourcing, aka buying stuff, and bills of materials. And so the bills of materials that you might make for your open source projects. So before I get started, maybe how many of you have designed something and then put the design out on the web and shared it? Okay, cool. And then how many of you thought that your bill of materials was a really important part of that? Most of you, so yeah. Let's all agree that bills of materials are super important. We teach this class at MIT called How to Make Almost Anything that I bet a bunch of you are already familiar with. Using a set of standardized tools and materials, such as the ones that are available in the Fab Lab. In case this is really boring, who hasn't heard of a Fab Lab? Okay, so I'll skip through that. This is one in Iceland, actually. If you guys have the opportunity to visit, it has all of the tools nicely displayed in a way that you can take a photo of them all at once. And so a part of it is having parts in the inventory in the Fab Lab as well, parts that you can make things with that you can, for example, take home and use to continue making things outside of the lab. I kind of think of the lab as maybe a library that people might go to, use tools that they don't necessarily have access to at home, and maybe they'll take something back with them and use it at home. So for example, one of the first circuits that people might make when they come to a Fab Lab is an ISP, and so then they make an ISP, then they can take it home and program their own microcontrollers. So maybe the circuit board they have to prototype in the Fab Lab, but they can work on the firmware when they get home. And so to be able to have the materials that you might need to make things like ISPs, we have this Fab Lab inventory, which I like to jokingly refer to as the how to buy almost anything list. It has all of the things that you might expect for a Fab Lab inventory on it. So the laser cutter, the 3D printers. We have kind of a way where we decide what our favorite tool is at the moment. We put that on the inventory. And so for the Fab ISP, it has the right crystal, it has the right microcontroller, it has kind of a link to the microcode that you would need to load onto it. And because I'm personally interested in machine design and machine fabrication, I put lots of machine parts on it, or maybe a petting zoo of things that you might want to have around if you're thinking about making machines and digital fabrication devices. And we teach another class in the spring. I'm going to be teaching that starting in February, called How to Make Something That Makes Almost Anything. We should really maybe get more inventive with these naming schemes. But How to Make Something That Makes Almost Anything is a class where people use Fab Lab tools and processes to kind of think about how to make more digital fabrication tools. And so we have this website where a lot of the projects go online. And you can download the cut files and the bills of materials for a variety of different machines that we've made. Maybe some of you guys have seen machines that I've designed before. And they're not necessarily very well documented projects. They're machines that maybe we made once in a semester project, or maybe it was just a week hack. And so I kind of want to make this distinction between different kinds of open source hardware to kind of think about what are the affordances that are built in to sharing your bill of materials. So first of all, maybe something is open just so that you can see how it works. So you have a basic understanding of like what parts of your car do what. If you have a car. Who has a car? Jeez. And so maybe it's open so that you can see how it works and you can fix it. So old record players or old stereos, you know more or less where everything goes, and you could replace capacitors as they blow up or something like that. Or maybe you can build it from a kit, like the Ultimaker 3D printer. You can buy the Ultimaker 1 kit, and then you can build it. So you know what all the parts are kind of for. If something in the kit breaks, then you know how to replace it because you're the one who assembled it. And so maybe you know how to buy the parts that you need for the kit and also make them into the parts that you need to assemble the machine with. So how do you source the parts required for the kit? And that's more than just buying things, but also once you start thinking, oh, I can source this from here, or I might use this material, or you might use some other material, then you start thinking about, can you intervene in the design process of the machine itself, or whatever it is that you might be making, not machines. And so with the Machines That Make project, I want to focus on this one example machine that maybe some of you guys are already familiar with, in terms of like how this machine project informed making bills of materials. So the MTM Snap is a kind of a series of design experiments at the MIT Center for Bits and Atoms that started with people are coming in and they're making their own fab ISP so they can program microcontrollers, but they can't necessarily make their own circuit boards at home. And in the Fab Lab inventory, we kind of made the broad sweeping decision to include all 1206 surface mount parts as like an easy way for people to prototype different kinds of hardware. And so can you mill, and we use a Roland Medela to mill circuit boards to make surface mount and some through whole component circuit boards for people to prototype with. And so maybe people could come to Fab Labs and also make their own circuit board mills so that they could mill circuit boards at home and then program those with their Fab ISP, et cetera, turtles all the way down. And so Jonathan Ward, my office mate at the time, he came up with the ultra low-cost cardboard circuit board mill, which had some structural integrity issues. And so it was a fun design exercise. But then he came up with a slightly more robust one, which was a plywood circuit board mill, which was called the MTM A to Z because it had exactly 26 parts. And that kind of would work for a while, but then when it would get hot or if it would get a little bit moist, the plywood would kind of bend and warp, and then the rails would bind, and then it wouldn't be a circuit board mill anymore, and it would suck. And so we were kind of thinking about how can we get around this problem. And so we kind of thought, well, plastics is the future. And so I was perusing plastic vendor websites. Plastic from McMaster-Carr is pretty expensive. So looking at usplastics.com. And it turns out that HDPE, which is one of the two most commonly used plastics on the planet, is also commonly used in the US food industry or food service industry as cutting boards. And they come in these convenient colors, like blue for fish, and green for vegetables, and red for red meat. And so we started making these things out of this cutting board plastic, and we included that cutting board in the bill of materials. So the bill of materials for the MTM Snap, also because we kind of used a buckle design, where, I don't know if anyone, maybe you guys are familiar with my advisor, Neil Gershenfeld. He really likes it when things snap together. And so this machine's frame snaps together as kind of a buckle construction for the mechanical structure. So there's 5 vendors that you would buy the parts in this bill of materials for. We also included the tooling in the bill of materials. So what end mill do you have to use to route plastic? How fast should you route it? Those are all kind of included in this bill of materials. And I think that really led to it. Even though it wasn't a very well documented project, we didn't really do a good job. We didn't put up any step-by-step instructions of how to assemble it. It ran off of Gerbil, so you need the bill of materials also included an Arduino and then a shield that you could mill on another MTM Snap or on some other machine, and then solder the components for that to run the stepper motors. And a lot of people made it, despite it being a poorly documented, kind of crappy open source effort. And I think it was because the bill of materials was really well documented. And that's where I think that the benefit was also that people really liked this plastic, colorful look. When we would make the machines, we would name them different things based on which prototype we were working on. So we had like a green and yellow one, and we called it the John Deere machine. And then we had a red and yellow one, we called it the McDonald's machine. And then we started becoming like a little bit more flippant, and we called the light blue machine the fuck you Martha Stewart machine, because we were like, why does she have to co-opt that whole color? And then we made a white and green one, and that was the fuck you Eves Bahar machine. So we have, anyway. unfriendly. Moving on. And so, in general, like if you're doing a project and you're designing the bill of materials, if you're just doing it for yourself, you're like, okay, what's fast, what's cheap, and what can I get right now? And maybe that thing that you can get right now is like a stepper motor that you pull out of a printer that doesn't work anymore. But I think with open source hardware, it's not really something that makes your bill of materials accessible for other people to retool for their own purposes. So don't put end-of-life products in your bill of materials. It will cause you all kinds of grief. The MTM Snap at first used an end-of-life stepper motor in it, and then everyone would email us and be like, we can't source this. You know, what's the difference between unipolar and bipolar? And so make it reorderable and also replaceable. So if the question is, what's the difference between a unipolar and a bipolar stepper motor, maybe in the bill of materials there's enough of a description so that you understand, okay, what I need is torque, not necessarily 6 wires. And then also, like reuse, I think is a big thing here. The Form 1, the SLA 3D printer, which is not open source, so boo them. But they use a Blu-ray laser to cure the resin, and that's because that laser will remain sourceable for a long time. So choosing that particular wavelength to design their resins around is kind of a choice of re-harnessing an economy of scale that you can take advantage of, even if you're not necessarily a big player yourself. So for example, HDPE cutting boards. There's so many restaurants that require cutting boards. Some of them can turn into machines. And so I haven't necessarily seen a lot of people that use predominantly an MTM Snap to mill their circuit boards, which is maybe a little too bad, but this, or maybe not, it wasn't such a great design. But there are a lot of people that are using this kind of HDPE snap-fit connection as kind of a design paradigm. James Coleman made this 5-axis milling machine. This is a liquid handler that I made with Enzo de los Santos, sorry for misspelling your name, Enzo, and Scott Livingston. Yoav Sturman made this 3D printer lathe hybrid. And so this kind of takes the cutting board and then moves it into this other machine design paradigm. So it's not necessarily that other people are making exactly the same thing, but they're using things from the bill of materials to design their own products. So now, other machines that I've been working on, I include a lot more information in the bill of materials than I used to. So I like making things out of aluminum right now. So what type of alloy are you using? 3031 is really ductile. I bend a lot of things, so you need a ductile aluminum. And so that's the kind of thing that you might want to include in the bill of materials. This is like a relevant parameter. The fact that it's shiny or not shiny is not a relevant parameter. Or actually, no, it's super relevant. Shiny is super important. And also, instead of saying, okay, this is how much it cost and this is how much the total cost for the number of units that you needed for this machine, I say, okay, this is how much it cost when I bought it in May. Because people might look back at your bill of materials 2 years later and say, oh, I want to buy this part. Now I'm pissed at you because you said that this bill of materials was $400 and I put everything in a cart and it's $560. You owe me money. And just a thing that I've started to explore also with the machine building is, can you work with small volume suppliers to make different things? This is a LED market in Shenzhen. We're walking around there, and I ran into Alicia, which was awkward. No, not awkward, super awesome. But you can go up to someone there and say, hey, I want an 0805 sideways shining pink LED. And they're like, okay, nobody else wants that, so we don't have that. But come back tomorrow. And so one way that you can reduce the complexity of your bill of materials is by perhaps looking for certain parts that you might want to replace with customly tooled bits. So these are some motors that I bought or ordered, and they have an integrated lead screw in the stepper motor, and they come with a wear compensating lead screw nut, and they're 4-start, which is super baller. And one of the things that it does for the small format milling machines like the MTM Snap is you kind of reduce the number of line items on your bill of materials. So yes, you're introducing a custom part, but at the same time, now you don't need helical couplings or thrust bearings or other things that you might have if the lead screw wasn't integrated. So, I don't know why I'm talking about this. You should talk to Eric about it. And so I guess the thing I really wanted to say was pay attention to your bills of materials so that it's easy for me to copy whatever it is you're doing. Thanks.